Hi and hello dear friends. Welcome you all once again to our channel, Vage Academy of Mathematics. So this session we have the question paper of 2011 December UGC-NET Paper 1. And once again we are here to solve questions from Arithmetic and Reasoning Concepts. Right? We go. But before that, here about this question paper, we have really very challenging questions. We of course have very nice and challenging questions from all concepts that we have seen already. So I would request you to stay with patience, and if you have the real passion to solve all the questions, if you are really interested, you wait till the last minute of this video, this session, so that you'll be getting benefited. And also I would again request you to stay with patience, because this video may run for, this session may run for more time. So hold your patience if you want to learn. Yeah. With this request, yeah, let me start with the questions. Our first question. So our first question is from percentage and also a mensuration based question. Okay. So it is dealing with both the concepts of percentage as well as mensuration. So question number 1. We have already seen this kind of similar question in our previous sessions itself. While we are solving problems from the previous year's question paper, we came across such questions. A similar kind of question is what we have here also in this year also. Yeah, let's start with the question. Given if the side of the square increases by 40%, so that is we have a square and its side is increasing by 40%. We already know about a square, right? So if we have a square, we have 4 sides, and also we know that the sides are equal. All the 4 sides are equal in length, and here they're asking that if the side of the square is increased by 40%, then the area of the square increases by what percentage? We have the options. So this is our question. So once again, let's just revise about how to find the area of a square. So area of a square, we know very well. It is nothing but side into side, right? We have already seen this. In our previous videos itself, we dealt with few problems based on area of the square. There we did this kind of questions. Area of a square is side into side, the same formula. Okay, we are going to use here also. But what happens is here they are given the side of the square is going to increase by 40%. So let's do a thing. Once again, we will just consider about the original quantities and the new quantities. Is that fine? Okay, original and new. Let me just construct 2 columns, that is original and new. So I'll note the original values here and new values here. Fine? Yeah? Yeah, yes. So yeah, now we will just start with assuming the side. And once we know what is the side, we can easily know what is the area also. Fine? Yeah? Yes. So let's have the original side of the square to be, as usual, 100, because this is how we start whenever we deal with a percentage question. Assuming 100 would be very easy for us to follow and do the calculation. So let's do the same thing. So original side, let's assume it to be 100. So what happens to the original area? We know very well area is nothing but side into side. So that means we need to do 100 into 100. Is it or not? So what is 100 into 100? 100 into 100 will give us 10,000. Is it or not? Yes, it is 10,000. So that means our original area of the square will be 10,000. Yeah, let me note it here and come to the new side. So come to the question basically. So here in question, it is given that the side of the square increases by 40%. It is given side increases by 40%. Already our original side, we assumed it to be 100. So now what happens is this side is going to increase by 40%. So now what happens is the new side will become 100 plus 40% of 100. We know very well 40% of 100 is just 40 itself. So that means our new side will be 140. Okay. This essence also we have already learnt in our previous questions itself, because any percentage of 100 will be the same number itself. Is it or not? So that means if I want to calculate what is 40% of 100, we'll be getting 40 itself. So what happens? 100 plus 40 we do, we'll be getting 140. So that means new side will be 140. And what about the new area? So if you want to calculate the new area of the square, what happens is, so we have to do, now the side is 140, right? So that means now the new area will be 140 into 140. This is all we have to do. Okay. Yeah, fine. So now what can we do? 14 into 14. If you know 14 tables, we can easily do this. We know 14 14s are, you can even try and get it. 14 14s are 196. And we have 140 here and 140 here. That means we have to insert 2 zeros here. Do you understand this? Yeah, because I know very well 14 into 14 is 196. And 0 and 0. These two zeros we are just inserting. I mean, following that 196, we are inserting these two zeros. So that means we are getting the new area to be 19600. This is going to be the new area. So we are now asked to find what will be the change in the area of the square. So this also we know very well. So how do we find the percentage change? Usually how we find the percentage change? Percentage change will be nothing but percentage change, whether it is percentage increase or percentage decrease. What we usually do, we do this calculation, right? If you remember, we do difference by the original value multiplied by 100. So difference by original into 100. This we do, we can get the answer very easily. So let's see what is the difference. Okay, see the original area and see the new area. What is the difference between these two values? This is 10,000. This is 19,600. That means we have to take the difference between these two values. Okay. So that is, we have to take 19600 difference. That means minus 10,000. This is what is difference. Is it or not? So when I do this minus, when we take that, difference is basically meaning subtraction only. That's it. Okay. So we do minus. So when we do minus, what happens? We'll be getting 0, 0. Here we get 6. Here we get 9. And 1 minus 1 would give us only 0. Okay. So that means we are getting the difference to be 9,600 divided by, what is the original area? Original area is actually 10,000. Let's put it here into 100. So this calculation would get the answer. So this 00 and this 00 we can cancel. And once again, this 00 we can cancel with this 00. So finally our answer would be 96%. 96%. See here, we are left with only 96. Is it or not? So that means what happens to the new area? Our new area will be increased by 96%, which is matching with option D, and that is going to be the answer. Okay. Yeah. The same kind of rule. So we did some previous, in our previous sessions, we did a similar question like this. There also we dealt with area of the square only. If you have any doubts or if you want to have more clarity, you can even view that video and come, you'll get more clarity here. So what we do is we just start with assuming the original side 100, that gave the original area 10,000, and new side is 40% more. That means it becomes 140, and so area will become 19600. And they're asking how much percentage is increased. Okay, that means we are supposed to find percentage change. So percentage change is always equal to difference by original into 100. So difference is nothing but the difference between the original area and the new area. That difference we took, 9,600 we got, we put it in the numerator, divided by the original area. Original area is 10,000, that we put in the denominator and into 100. Okay, now on simplification we get the answer as 96. Sure, 96. Okay, so that means option D, which is matching with our answer, is our final answer. Yes, let's move on to the second question now. Yeah, question number 2. Here we have our next question, question number 2. Given here, there are 10 lamps in a hall. Each one of them can be switched on independently. Then the number of ways in which the hall can be illuminated is, that is, in how many ways we can light the hall. That's all. The question is very simple. In how many ways we can light the hall. That's all. So there are, how many lamps are available? There are 10 lamps available. Again, if you see, a very similar question we have done some few sessions ago. I think some 2 or 3 sessions ago, while we were solving this kind of previous year's questions, we got a very similar question there, but there we got it as true or false questions. If you remember that video, we have seen it as true or false questions, 10 true or false questions, but here we just have it as 10 lamps. That's all. We have 10 lamps. So let's do a thing. So we will just put 10 empty slots here. Okay, so 1 2 3 4 5 6 7 8 9 and 10. Is that fine? I think I have drawn 10 slots. Yes. So how many ways we can light it? How many ways we can illuminate the hall? That's all. The question is very simple. Okay. So now we have to see each of these slots has one lamp. Okay. So this is one lamp. This is the first lamp. The second slot where we have drawn, this is the second lamp. Okay. This is the first lamp. This is the second lamp. This is the third lamp, and so on up to this one is the last 10th lamp. Okay. Likewise, we have 10 slots where, as I told, each slot stands for one lamp. Okay. So in how many ways it can be illuminated? This is our question. Now see the number of ways we can fill each of these slots. Okay. So now see the first slot here. How many ways we can fill this? First slot, that means this is the first lamp. In how many ways I can fill this? Or that means, in other words, if I want to ask, I can just either on the lamp or keep it off itself. Is it or not? Whether I can light it on or I can leave it without making it on. I can just keep it in off status itself. That means I can have this lamp in two ways. Either I can on or keep it off. Same way, come here, the second lamp also, either I can on or keep it off. Same way, third one, two ways, fourth one, two ways, and so on. Okay. Likewise, into, because we are keeping all the 10 lamps, right? This is like first lamp, two ways, and second lamp, we have two ways, and third lamp, we have two ways, and fourth lamp, we have two ways, and so on up to the last lamp. Till the last lamp, we have two ways. So that means 2 into 2 into 2 into up to 10 times we will have. So when you write it in a simplified way, what happens is you will be getting 2 power 10. This is going to be the answer. Actually, if you want to calculate the numerical value, we have to just multiply all these twos and then get the answer. That you would get it to be 1024, because if you remember the previous year's questions, we solved this question, and there we got the numerical value of 2 power 10 itself. There we got the answer as 1024, but we don't have 1024 in our answer choices. See here, we have only 1023. It's a trap answer. We should be very careful with that. But we have directly given to be 2 power 10. This option is available at option C. So that means option C, 2 power 10, is going to be the correct answer for this question. Okay, once again, a straightforward question from this number of ways. Okay, so just 10 slots, each one can be filled in two ways. So 2 into 2 into 2 into up to 10 times. So that can be written as 2 to the power 10. That's all. So 2 power 10 is directly available in the options. We need not even simplify and get the numerical value. Not needed at all. Directly we just tick that 2 power 10. That's all. That is our answer. Fine. Let's move on to the next question. Question number 3. So here, once again, a very good question we have. I think to solve this question, we need to take a little time. Okay, because this involves more of logic. So that means we need to solve this question with a great patience, and also let's not try to solve this in a very quick way. Okay, so math students who are very much comfortable with such topics, actually this topic they call it as permutation and combination. Okay, the concept under which we are getting this third question, we call it as permutation and combination. Students who are experts, mathematics students who are expertised in this topic, they would take only just seconds to solve. But being art students, it is important for us to spend some time on it and then go with the question, solve it very carefully step by step. That is very much important. Okay, yes, so let's carefully go see this question. Question appears to be very simple. How many numbers between 100 and 300 either begin or end with 2? This is my question. So the question appears to be very simple, and also it is very easy for us to understand. So how many numbers between 100 and 300? So what do you mean by that? Between 100 to 300. In this range, I have to see. Okay, that means what are all the numbers I can have? I can have the numbers 101, 102, 103, up to I can have, what would be the last number of this list? It would be 298 then 299. Do you understand this? I think you are clearly able to understand this, because they are asking 100 to 300. So that means 101 to 299. All these numbers will be present in that list. Okay. Of these numbers, see our question, of these numbers, how many of them either begin or end with 2? This is my question. Okay, so that means what all the numbers are, how many numbers we have in this list, out of which we'll have the numbers either they will start with 2. I mean, we are very sure that all of them are 3-digit numbers only. Is it or not? They are all going to be 3-digit numbers only. How many of them will be starting with the digit 2 and some other digit and some other digit? Or how many of them will have 2 to be the ending digit? That is some digit, then some digit, then the last digit will be 2. I think you are able to understand. Okay. In this list, I mean, from the numbers list 101 to 299, from 101 till the last digit, last number 299, how many numbers can we find such that they will either begin with 2 or they will end up with 2? This is our question. Very simple question. But what approach are we going to take to solve this question and get the answer? This is where our logic lies. Okay. This is where our calculative mind should work. Okay. Yes. So let us just do a thing. Okay. Let us just do the calculations individually. I mean, let's try to do it step by step. Okay. I mean, what I will do is, first I will take like this. How many of these numbers will begin with 2? Let's start from here. So how many of these numbers will begin with 2? I mean, 2, then a digit, then another digit. Okay. Likewise, how many numbers here in this list we will have starting with the digit 2? From here we will think. Okay. Then next what we will do is, how many of the digits will end with 2? This also we will think. Okay. I mean, first digit, second digit, and the last digit will be 2. I think you are clear with the point. I'm going to individually calculate, okay, how many of these numbers will start with 2, and how many of these numbers will start with 2, and how many of these numbers will end with 2. This one we will individually calculate. Okay, let's see how far this is going to help us in getting the answer. Yeah, let's start now. So let's start from here. How many of them are going to start with 2? Okay, I think you yourself can make that plan. How can we think of these numbers? So what are all the numbers we have in this list starting with 2? Think like this. What is the least number we will have starting with 2? It's very easy for us to say 200 is the first number, or 200 is the least possible number where we will have starting with 2. And what would be the next number? We can have 201, we can have 202. So this list will go. What would be the last number in this list? Very easy to say, 299. I think you're able to understand it, right? Very simple to analyze it, right? So in this list, I mean 101 to 299. If I want to check what are all the numbers will start with 2, I mean the starting digit will be the digit 2. Then what should I do is, the starting digit should be 2. That means I have to go start from the least possible number. That least possible number itself is 200. Is it or not? So 200, 201, 202, and so on it goes. And what is the largest possible number coming in this list? We can have 299. So these are all the numbers that will have the starting digit as 2. And now tell me, now clearly answer my question. Now clearly tell me, you yourself try to tell me, how many numbers are there here in this list? I mean, from 200 to 299, how many numbers are there? Just think of and say. So 200, 201, 202, 203, and so on up to, if we count till 299, just tell me in the counting process, how many numbers will we be able to find? That we have to think. So how many numbers are there? Yeah, we have totally 100 numbers here. Is it or not? Because we start from 299 and we end up with we start with 200 and we end up with 299. Okay, it's very logical to say. See here, it's very logical. From 201 to 299, we have 99 numbers. Just add 200 with it. I mean, 200 means the number 200 with it. Then what happens? We will have one more number in that list that will become, and the list will become, it will have 100 numbers totally. So that means in that same list, we have got a total of 100 numbers which are going to start with 2. Okay, so I'll put an equal to symbol and I will put 100 here. Do you understand this? 100. Yes, fine. It's so logical, right? Yeah. Now let's come here, ending. Okay, so how many of these numbers, I mean the same list, I mean starting from 101 and ending with 299, how many of these numbers, now we have to think they will end with 2. This we have to think. Okay, so how can we just think this? So how to make a thinking like this? Again, we have to go for the least possible number. Can you see the least possible number in this list which is ending with 2? We have that number in front of us itself. See here, we have the number 102. So this is going to be the least number that will end with 2. Is it or not? 102 is the very first number, least number that will end with 2 in our list. I think you're able to understand it, right? And can you think of what would be the next number that will end up with 2 in the same list? Just think the next number that will appear in the list, and at the same time it should end up with 2. What can be the next number? So I had 102, that is my first number. Then I will have 103, 104, 105, 106, 107, 108, 109, 110, 111, and then 112 comes next. I think the logic is very easy for us to follow. Is it or not? 102, then 112 is the next number. Then what would be the next number? 122. Then what would be the next number? 132, then 142, and so on. The list will go like this. Okay, I think you're able to understand this. 102, 112, 122, 132, 142. Likewise, it will be going. Okay, I think you're able to understand the logic, and it will go till where? That also we have to think. Okay, it will go till where? And also one more thing we have to think, how many numbers are there in this list? This is what we just need it. Okay, this is all we need. Very simple. So 102, 112, 122, 132, this list is going. I mean, we are taking numbers in such a way that the ending digit is 2. That is okay. But how many numbers can we find like this in this list? This is all we need. Okay, then what can we do? I'll just give a simple idea. Okay, or I will just give a simple technique. How can you get the answer? Okay, fine. Yeah, let's work it. Okay, because all the time we cannot list all the numbers and then have a counting. It will drag our time. Okay, so how can we now think? So let's do a thing. Okay, I know 102, 112, 122, like this it goes. Just see, all these numbers are hundreds number. Is it or not? 102, 112, 122. It goes like this. And what would be the last number coming in this hundreds list? You can surely tell that it would be 192. I think you are clear with this. Is it or not? So in that hundreds family itself, I'm able to find, see, 102, 112, 122, like so on, like this. And I can end up with 192. Then next go for the 200s family. In 200s family, from what number can we start? 202, 212, 222. Then it goes like this. And what would be the last number that will come here? 292. Like how we started with 102 and ended with 192. Same way we can start with 202 and end with 292. Okay. So that means these are all the numbers we have which are ending with 2. Is the point clear? See here, now I can very easily say that there are 10 numbers here in this first list and 10 numbers here in the second list. So that means totally how many numbers we are able to find here which are ending with 2. See here, I got 10 numbers in the hundreds family, 10 numbers in the 200s family. So that means we have a total of 20 numbers which are ending with 2. Is the point clear? Yes. I think I'm moving very slowly just for the reason you need to understand it. That's my ultimate point. So I'm writing the numbers individually and I'm showing you the logic. So 10 numbers here and 10 numbers here. Now think this, we need not exceed this 292. What happens if we exceed it? What will be the next number? We will now have to enter 300s family. Do you understand this? So once after 292, just concentrate on this. 292, just after this 292, my very next number that will be coming in the list is 302, 312, 322. The list goes like that. But see here, we are allowed up to use only 299 because strictly in the question itself it is delivered that we have to take numbers between 100 and 300. So that means this is going to be the last. So that means we have only 20 numbers in the list. Okay. So fine, we are success. Okay. But hold on, our problem is not yet over. We now took the list of numbers which are starting with 2 and which are also ending with 2. Is it or not? So we finished, we completed that list. But is our task over? Can you just think of, just make a logical calculation whether we have completed our calculation? Okay. That means what I mean is, so we got numbers with our starting with the digit 2 and numbers with the, which are ending with the digit 2. Everything is over. Here we got 100 numbers, here we got 20 numbers. So we can add 100 plus 20 and that means 120 is the answer. Can we conclude like this directly? Is it possible? No, it is definitely not possible. Why it's not possible? Yeah, here is where the careful step lies. Okay, so this step is what is even more important. So doing our calculation till this is not enough. Even after this, we have to make one calculation, make one case, think of one case which is nothing but both. That is, both the digits are 2, not 2 and 2. This is where we have to think. Okay, see here what happens is, we accounted the numbers which are beginning with 2. There we got 100 numbers. And we also accounted the numbers which are ending with 2. There we got 20 numbers. But see, listen one thing. Are these lists going to be disjoint? I mean, are these lists going to be without any intersection? I will have some numbers which are starting with 2 and also ending with 2. That means those particular numbers are going to be double counted. Is it or not? That will come in this list and also this list. Is it or not? So that will appear in both these lists. So that means I will have 100 which is going to be inclusive of that numbers also. I will have this 20 inclusive of that numbers also. So that means in order to avoid the double counting, what should we do? What are we supposed to do is, we need to subtract those numbers which has 2 and 2 in starting as well as ending digits. This is what we have to just calculate. Okay, so how many numbers do we have such that my starting digit as well as ending digit is 2? That we have to think. Okay, I think this is very, very easy for us to say. See here, my starting digit is 2 and my ending digit is 2. That means my first number itself will be 202, then second number will be 212, third number will be 222, fourth number will be 232, and so on up to 292. Is it or not? So that means how many numbers are here? There are just 10 numbers here. Is it or not? So these 10 numbers will be there in this list and also this list. Is it or not? So for that reason, what we are supposed to do is, in order to find the total value, I mean the total set of numbers, if I want to find, what I have to do is just do this 100 plus this 20 minus this 10. So 100 plus 20 will give us 120 and 120 minus 10. So what is 120 minus 10? Final answer will be 110 and that will be our final answer, which is matching with option B, and that is going to be the correct answer. Is the point clear? So option B, 110 is the answer. Once again, let me repeat it. We just started to take how many numbers are starting with 2, that is 100. And we calculate how many numbers are ending with 2, we got it to be 20. Everything is fine. These two are fine. Okay, this 100 is okay. This 20 is okay. But what about this 10? Here is what we are doing. What we are actually doing here. It's very simple. Nothing is done here. See, there are some numbers which are starting with 2 and ending with 2 that would have appeared in both of these lists. Okay, I should not count it here and once again here. In order to avoid the double counting is what? I'm just subtracting these 10 numbers from this total 120. So 120 minus 10 is what is giving us 110, and that is going to be the final answer, which is matching with option B. Fine? Yes. Let's move on to the next question. Our fourth question. This is once again a very good logical question, that is dealing with numbers. Okay, so most questions, more than calculations, we have to use our logical thinking also in order to get the answers. And as I told, we have very interesting, very nice questions here, which is just keeping our minds waking. So such questions are what we can actually expect in our exams also. So get ready for these kind of questions also. Okay, not just practicing only very simple questions. These kind of questions also help us to get the answer, and through which it would help you to boost your score, right? So that is much important. Yeah, let's just work the fourth question. So the question says, in a college we have 300 students. Yeah, let us note it. In a college, there are, how many students are there? There are 300 students. Fine. Okay, there are 300 students. Let's make a note of it. Totally, there are 300 students. And what other informations are given to us? Yeah, let's make a note of it. And it is given that every student, see here, every student reads 5 newspapers, and every newspaper is read by 60 students. Okay, yes, okay, these kind of statements are what immediately will start to confuse the students. Okay, but hold on, let's not make much pressure. Okay, let's try to understand the meaning very easily. Okay, so there are 300 students in a college, and what is this? There are some magazines, some newspapers are there. Okay, and the rule is every student reads 5 newspapers. This is the condition. So if there's one student, that one student is supposed to read five newspaper. One student is reading 5 newspapers. Okay, this is what is the statement saying. And one more information is also given along with this. Every newspaper is read by 60 students. Every newspaper, that is, if there's one newspaper, that one newspaper will be read by 60 students. Okay, so every student should read exactly 5 newspapers, and every newspaper must be read by exactly 60 students. So two conditions we have here. Then finally, what is the question? Then the number of newspapers required is how many? This is our question. Okay, yes, let's carefully deal with this question. How can this be answered? So as we told, let's do a thing. We have two conditions given here, is it or not? That is, there are newspapers and also students, and given every student reads 5 newspapers. Okay, if there is a student, he should read 5 newspaper, and every newspaper is read by 60 students. Okay, let's start from that 60. Okay, let us start from 60 because we are asked to find how many newspapers are there. So let's start from the number of students itself. Okay, so given that every newspaper is read by 60 students. Okay, yeah, okay, so that means let's have it like this. Paper 1, newspaper 1. Newspaper 1 is there. This newspaper 1 will be read by 60 students. We'll have it like this. Okay, yes. Next, what we will have is, again, once again, we will even have like this. Okay, paper 2. Paper 2 will be read by 60 students. Next, we will have paper 3. Paper 3 will be read by 60 students. Next, we have paper 4. Paper 4 is also read by 60 students. And last one, we will have paper 5. Paper 5 is also read by 60 students. Do you understand this? Yeah, here is the situation. You may wonder, why should we necessarily do such kind of things? Why we have to take paper 1 read by 60 students, paper 2 by 60 students? Why are we taking like this? And why we are taking paper 1, 2, 3, 4, 5? Why are we doing like this? See, the question itself, it is given like that only. That is the reason we are taking like this. Now see the condition, whether our question's condition is satisfied or not. Let us see now. Okay, now every newspaper is read by 60 students. Is it happening or not? That we have to think. Okay, every paper is read by 60 students or not? If we take paper 1, yes, paper 1 exactly 60 students are reading. Take paper 2, yes, paper 2 is also exactly 60 students are reading. Okay, paper 3 also exactly 60 students are reading. Paper 4 exactly 60. Paper 5 is also exactly 60 students are reading. So if I take any of these paper, exactly 60 students are reading the paper. Okay, fine, yes. Now the next thing is the other condition. Every student read 5 papers. That is, see here, I have 60 students here. Okay, there are 60 students. I will even just mention 60 students. Now each of these 60 students, listen carefully, each of these 60 students are reading 5 newspapers. So I have 60 students here. If I take the first student is reading all the 5 papers, paper 1, 2, 3, 4, 5. Same way, the second student here will also read the same 5 newspapers, 1, 2, 3, 4, 5. Third student would have read the again the same 5 papers, 1, 2, 3, 4, 5, and so on. I will find each student reading 5 newspapers. Okay, so that means to get this setup itself, in order to get this condition satisfied itself, we are making this set of 60 students reading 5 newspapers. Okay, do you understand this? Only then we are able to satisfy the questions condition. See here, 5 newspapers and then 60 students. Okay, this way we are having. Now what happens is they're asking how many newspaper is required. This is our question. Okay, so what can be done here? Now what next can we do here? See here, now we are so far able to account only 60 students, but actually how many students are there in that college? There are 300 students. So that means what I can do, I can assign one more set of 60 students. See here, one more set of 60 students I can assign. Then I can do the same thing, P6, P7, P8, P9, and then P10. That is the next 5 magazines or the next 5 newspapers I can take. And once again, the same thing happens. Each of these 60 students will read these 5 newspapers, and each paper would be read by 60 students. Do you understand this? So that means I can take set of 60 students, and I can assign 5 papers to each of those 60 students. So that means my answer, what would be the answer? How many number of newspaper is required? The number of newspapers required is how many? This is my question. Okay, so that means just think like this. If you assign 60 students 5 newspapers, another 60 students another 5 papers. Okay, likewise, how many set of 60 students do we need? 60 students, we assign 5 newspapers. 5 newspapers. Okay, then how many students do we have totally? We have 300 students there. Okay, for each 60 students, if we want 5 newspapers, so for totally 300 students, how many newspapers do we want, or how many sets we need? We need 5 sets of students. Okay, 65 are only gives us 300, right? So that means we need 5 set of 5 newspapers. So 5 5s are will give us 25 newspapers. So that means 25 newspapers, which is option C. We need exactly 25 newspapers to make this conditions satisfied. That means option C, 25 is going to be the answer for our fourth question. Okay, a little challenging, tricky question from numbers we are asked. So this is how we answer this. Yeah, fine. Let's move on to the next question. Yeah, here our question is based on graphs. Okay, so we have a graphical question given here. Yes. So under this graphs itself, we have 2 questions. This is question number, actually we finished till 4, right? So that means this is question number 5, question number 6. The questions appears to be very simple only. It's just going to be percentage calculation only, because see this graph itself, this itself is telling us what logic should be used here. Yeah, anyways, we'll see the question. The total carbon dioxide, CO2 emissions from various sectors are 5 mmt. That means the total emission is 5 mmt. Then the chart below is giving under what are all the sectors, how much percentage is emitted. Okay, this is what is given. Okay, so that means domestic sector we have 15%, commercial sector we have 20% emission, transport we have 30, thermal power we have 35. Let's check it whether we are getting the total to be 100. Okay, 15, 20, 30, 35. Just add it and see. Yes, we are getting 100 only, right? Because it's easy for us to see. 35 plus 15 will be 50. This 30 plus 20 will be another 50. So total 50 plus 50 is 100. Yeah, verified. So for each sector, we have different percentage values. And let's now come to the question. And also one thing to be remembered is, what is the total emission is what? The total CO2 emission is also given. Total CO2 emission is 5 mmt. Okay, that mmt should be some measure of emissions, it may be. So anyways, total is 5 mmt. We'll note it. And out of this 5 mmt is what is it? Is what is split like this. Okay, now let's go to the question. What is the absolute CO2 emission from domestic sector? This is our first question. Let me take this page. Okay, question number 5. So question number 5, they are asking what is the emission we can have it from Domestic, okay, domestic is 15 percentage. So that means what calculation are we supposed to do? We should do 15 percentage of 5. Is it or not? Because the total emission is 5 MMT only. Is it or not? So that means 15 percentage. That means 15 by 100 into 5. Very simple. This calculation would even give the answer. Okay. 15 percentage of 5 can be done like 15 by 100 into 5. Very simple, right? So that means what can you do? 15 5s are 75. So 75 by 100 is going to be our answer. So when I just express this in decimals, what would be the answer? 75 by 100. We have 100. We are dividing by 100. Dividing by 100 is very easy, right? Just we have to move 2 decimal places to the reverse direction. Okay, that means we will be ending up with 0.75. Because we have 75 by 100, I need to move 2 places decimal. Okay, 2 places to the left. So I will get 0.75. That is 0.75 MMT to be the answer. So 0.75 MMT is at option D. Right? Very simple. Percentage calculation is helping us to get the answer. Yeah, we'll move little more down because we'll get some extra space. We have one more question here. Let's see what question is that. Yeah, question number 6. Question number 6. Yeah, question number 5, they asked about domestic sector, right? Domestic sector, we got it to be 15%. So we calculated and we got the answer. Now come to the 6th question. The question is how much percentage, okay, absolute CO2 emission for the combined thermal power and transport sector. Okay, so that means this thermal power, I'm sorry, yeah, this thermal power and then transport combined they're asking. So thermal power is this 35 and transport is this 30. So combined is how much? This is what they're asking. What do you mean by combined? So combined is very simple. This 35 along with this 30 added they're asking. Okay, I think I have striked that 35. I'll just once again, yeah, now it is clear. 35 and 30 together they are asking because thermal power is 35, transport sector is 30. So that means together they are asking. So together means all we can do is just we can directly add the values. Okay, 35 plus 30. So what is this 35 plus 30? Let me work it here. Okay, because I know thermal power is 35 and I know transport is 30. So 35 plus 30 will give us 65. So what is the 65? 65 percentage. So 65 percentage of what number? Again the same number only, 5. Okay, because we know that the total is 5 MMT. Is it or not? See here, total is 5 MMT. It's already there in the question. So 65 percentage of 5 is what we need to find. Why it is 65? They're asking these two sectors together. That means we can directly add. Okay, 35 plus 30, 65% of 5. This we can calculate. So 65 into 5 will give us 325 by 100 we have to do. So this again we can answer in the same way how we did 2 decimal places in the reverse direction. Here also we can do the same thing. 325 by 100. Just move 2 places to the left hand side. We will be getting 3.25 MMT. So 3.25 MMT is at option A, and that is going to be our answer for our 6th question. Yes, okay. Yeah, fine. So again, here this session we solved 6 questions. All these are from different areas, but little challenging than compared to our previous year's question paper set of questions. Anyways, we did some questions, very interesting questions, very challenging questions as usual. Any doubts you have, you can sure post it in the comments. You are welcome for that, and we'll definitely help you in clarifying your doubts. Okay, again in our next session we'll come out with other set of questions. See you soon there. Thank you so much. Bye.